Okay, what is the product of the roots of this equation? Okay, now this equation is a quadratic equation. Suppose I have a quadratic equation. I am having negative value over here, so I just take equation accordingly. So x minus a x plus b is equal to 0. So it is x square minus so product of the root is this constant term is minus ab, and but the product of the root is a into minus b, right? So constant term is nothing but the product of the roots, okay, with same sign. So here x square minus root 3, so constant term is minus root 3, so product of the root will be minus root 3 only. Okay, do not change the sign. Uh, if x plus y is 15, then x minus 10 whole cube plus y minus 5 whole cube. See, whenever students see this sort of problem, they just start solving it, right, without thinking a bit. See here what is happening. X plus y is 15. How many combinations can you tell me when x plus y is 15? You can tell me so many. 2, 13, 3, 12, 10, 5, 5, 10. So many combinations are there. Then how can I get a single value for this expression? Right, x minus 10 whole cube plus y minus 5 whole cube. Different combinations of x and y will produce different values, but since in this case only one of the option is correct, that means it gives a single value. That means whatever is the value of x and y when x plus y is 15, you will be getting a single value, single solution for this problem. That means you choose any value when x plus y is 15, right? So what you can do is, to make it very easy, just to make this 0, I just choose x is 10 and y is 5. So 10 plus 5, 15, and you'll be getting the answer very simply. So when x is equal to 10, this expression will be 0, y is equal to 5. So this expression will also be 0, right? So precisely the answer to this problem is 0. If you think or not confident, then you can choose other values also. Suppose you take x is equal to say 5 and y is equal to 10. So if you take x is equal to 5, it is 5 minus 10 whole cube, that is minus 5 cube, right? And here it is plus 5 cube, right? Y is equal to 10, so 10 minus 5 plus 5 cube. So minus 5 cube plus 5 cube, still you are getting 0. That means whatever the value of x and y you choose when x plus y is 15, always this expression will be 0. Okay, so do not try to make any sort of equation. No paperwork is required at all. It's a just 20-second problem. If x is this, value of this. Now just look at options. In options you have been given root 2, root 2, root 2. That means we need to eliminate root 3. So that is possible only when we take root 2 this side and root 3 keep in the right hand side. So when you square the expression, root 3 is eliminated. That's root of this 3 is eliminated. So x minus root 2 whole square is equal to 3. So x square minus 2 root 2x plus 2 is equal to 3. So this is actually 1. Now x minus 1 upon x cube, we have done so many sums on this pattern. We want x minus 1 upon x and x square plus 1 upon x square, right? Factorization of this is this. Okay, now how do I get x minus 1 upon x? Divide the entire expression by x. So x minus 1 upon x, if I take this one this side and divide the entire expression by x, I'll be getting x minus 1 upon x as 2 root 2, right? So x minus 1 upon x I got. I want x square plus 1 upon x square, so just square it. X square plus 1 upon x square minus 2 is equal to 8. Okay, so x square plus 1 upon x square will be 10. So this is 10 plus 1, 11 into x minus 2 root 2. So it is 22 root 2. Pretty simple. The term to be added to this to make a perfect square out. That's very simple. See here it is 11a whole square. Here it is 8b whole square. So it is a square plus b square. If we add 2ab, then it will be perfect square like a plus b whole square, right? So 2ab is what? 2 into a is what? 11a, and b is what? 8b. Okay, so what we need to add, 11 into 2, 88 into 2, 176 ab. 176 AB. Pretty simple. X minus 1 upon x is equal to 1 when then the value of this. Okay. See, whenever in exam you see this, okay, just try to recall x cube minus 1 upon x cube format, x cube plus 1 upon x cube format, x square plus 1 upon x square format, right? Now, I have suggested you to get this format. Now, how do you get this format over here? If you just look at this expression carefully, x4 minus 1 upon x square, in the denominator and numerator and denominator, if you divide both by x, you'll be able to get this. See, x4 by x, it's x cube minus 1 upon x cube upon 3x square minus 3x minus 3 by x. I can take 3x common, x minus 1 by x and plus 5. Now the story becomes very simple for us. X minus 1 upon x, we already know that's 1. So 3 plus 1, 3 plus 5, it's 8 in the denominator. We have calculated, we have done so many sums when x minus 1 upon x is given, and we have to calculate this. So this is actually, now I'm not writing down the formula, it should be in your mind. X minus 1 upon x is equal to 1, that means x square plus 1 upon x square minus 2 is equal to 1. That means x square plus 1 upon x square is equal to 3. Now x cube minus 1 upon x cube is what? X minus 1 upon x, that is 1. Then x square plus 1 upon x square, that is 3 and plus 1. Okay. X cube minus 1 upon x cube is x minus 1 upon x, that is 1. Then inside the bracket it is x square plus 1 upon x square plus 1. So x square plus 1 upon x square is 3 and then plus 1. So precisely it is 4. So 4 by 8, 1 by 2. Okay. So bit twisted, this problem was not at all difficult, but whenever you see this, try to recall this. Okay. There is a single way out to solve this problem. Okay. If this expression is equal to 1 and a minus b plus c is not equal to 0, then which one of the following relationship is true? So this is a bit different question. Just listen to the explanation very carefully. Frequently asked question in competitive exams. Here I have been given a minus b plus c is not equal to 0. That means by some calculation you should be able to get this expression a minus b plus c over here. Right? Now what is the way to get this? See, I just copy this expression over here, b minus c by a plus a plus c by b plus a minus b by c is equal to 1. Now, a plus c should not be equal to b, precisely. Here a and c, they are sharing the same sign and b is opposite sign, right? So, here I wish to add or deduct 1 in such a manner when a and c should be having the same sign and b opposite sign, right? So what I can do is b minus c by a if I deduct 1. Okay, so what I'll be getting, b minus c minus a. That means a and c will be having same sign and b will be having opposite sign. So I deduct 1 from here. Plus here a plus c same sign and b should be opposite, so I will be deducting 1 from here also. Then plus a minus b and c same sign, so once again I'll be just adding plus because a plus c and minus b, it will be there. Now I have deducted 2, 1 and added 1. So this 1 and this 1 will be cancelled out, but since I have deducted a 1 from this side, I need to deduct 1 from this side. Okay. Now this expression story becomes very simple. B minus c minus a. B minus c minus a upon a. Then plus a plus c minus b upon c. A plus c minus b upon c. Then plus a plus c, here it is a plus c minus b upon c, sorry, here it is b, okay, is equal to 0. Now in this case it is a negative, right? So I just write negative sign and a plus c minus b. Okay, now what from the 3 a plus c minus b can be taken as common, right? So you are left with a plus c minus b, then you are left with 1 upon b plus 1 upon c minus 1 upon a is equal to 0. Now this is not equal to 0 as it is already mentioned over there. A minus b plus c should not be equal to 0. That means actually this is 0. If this is 0, 1 upon b plus 1 upon c minus 1 upon a is 0. That means 1 upon b plus 1 upon c should be equal to 1 upon a. So that's true. So bit twisted but interesting. So whenever you see this sort of expression, just try to arrange, add or deduct 1, right? So your denominator will be there in the numerator, okay, and all the expression in the numerator will become similar, same in fact. Okay, I have already done one problem earlier also. Just try to recall that. Now this problem, very simple. So many questions we have done on this pattern. A minus 2 whole square, that is a square minus 4a plus 4 is equal to 3. That means a square minus 4a is equal to minus 1, right? I want a plus 1 upon a. So what I do, divide the entire expression by a. So it's a plus 1 upon a is equal to 4. Okay. Then a square plus 1 upon a square plus 2 is equal to 16. So this is equal to 16 minus 2, 14 at 22nd problem. Now this problem, 4011 and a is this, b is this, find the value of a, b. That means precisely you have to find out the product. Okay, now product will be what? See, this is 4000 plus 11 and it is 4000 minus 11. So a plus b into a minus b, that is a square minus b square, right? So 4000 square minus 11 square. That's your answer. So 4000 square, 4 4s are 16, 1, 2, 3, 4, 5, 6, and this is 121. So from the last 30, that means from this 1000, 121 is deducted. The last 3 digits must be 879 and remaining should be 999. Okay, no 8 is required. The last 3 digits must be 879. We have over here. Here this 8 is wrong. Here this 8 is wrong. So this is correct answer. But that's possible only when you are able to recall that it is 4000 plus 11 and 4000 minus 11. Alternatively, what you can do, you can apply digital root concept as well. But for that also you have to be very careful because see, in case of digital root, if the numbers are rearranged, still you will be getting the answer to be same. Okay, I mean digital root to be same. Now what will be digital root of this? 4, 5, 6 into 9 and 9 is cancelled. 8 and 3, 11. That means 2. 6 into 2, 12. That means digital root is 3. Okay. Now we just see this option. 9s are cancelled. 9s are cancelled. 8 and 1, 9. 7 plus 5, 12. So digital root is 3 in this case. So in this case it cannot be 3 because we have one more 8. So this is eliminated. Even this is eliminated. But in this case we have 1, 8, 1, 7. So digital root of this will also be 3. And you can distinguish these two options from the third digit only. Right? So 4011 3989. If you can get the the third digit of this multiplication, then you can do it. For that, I have told you various times how to find out the last 3 digit of any product, right? See, if you divide this expression by 1000, this expression by 1000, then you'll be whatever is the remainder, that will be last 3 digit of this product. Okay, so what I can do is I divide this by 1000, so I'll be able to get the last 3 digits, so that is 011, and here remainder, right? 4011 divided by 1000, remainder is 11. 3989 divided by 1000, the remainder is minus 11, right? It is just minus 11. So finally it is minus 121. So if this expression is divided by 1000, the remainder is minus 21. Precisely the remainder is 1000 minus 121. Whenever you have negative remainder, just deduct it from the divisor. So last three digits must be 879. So this is the correct answer. Okay, so this is, you need to practice with this method. Though I have solved many sums in our number system session, but still you need to practice, right? When you have to find out the remainder, if you wish to have the last two digits of the product, then divide it by 100. Okay, suppose 109 into say 115. If you wish to have the last two digits of the product, divide the product by 100. So here it is 9 and here it is 15. 15 into 9, 135. So last two digits of this product will be 35. So that becomes very simple. Okay. Now this is once again, just see this and try to recall this. Is equal to 3abc when a plus b plus c is 0. Here a is 55, b is 17 and c is 72. So 55 plus 17 minus 72 is 0. That means this expression is nothing but 3abc. That is 3 into 55 into 17 into 72 negative. Then plus 201960. Bright chances are there the product of this is 201960. And this much risk you can take, right? So your answer must be 0. One step you can do, you can calculate the digital root. See here the digital root is 9 and here also the digital root is 9. 6, 7, 8, 9, right? So don't worry, it's the correct answer. Okay. X is this, y is this. For what value of k will be x is equal to y? We put x is equal to y. Let's see what happens. K cube minus 3k square is equal to 1 minus 3k. So it is k cube minus 3k square plus 3k minus 1 is equal to 0. That's nothing but k minus 1 whole cube. That's 0. That means k is equal to 1. Right? Pretty simple. X plus 2 by x is 1, then the value of this x plus 2 by x. Okay, problem is very simple. How do you get x plus 2 by x? If you divide this entire expression by x, right? So here it is x square by x and here it will be 2 by x. So it is x square by x, that means x plus x by x 1 plus 2 by x. So x plus 2 by x you got. Here it is x square 1 minus x. So if we divide the numerator by x, we need to divide the denominator by also x. So it is precisely x 1 minus x, or I can say x minus x square. Alright, now how do I get x minus x square? Let's see. Here if I take LCM, I'll be getting x square plus 2 is equal to x. So x square minus x is equal to minus 2. I want x minus x square, that will be 2. So x minus x square, this is 2. X plus 2 by x is 1. 1 plus 1, 2 by 2, 1. Pretty simple. This is also bit twisted. A square plus a plus 1 is 0, or we want a9. Now it's not easy to get a9 because a square plus a plus 1 is equal to 0. We'll be getting imaginary root of this equation, so it's not possible to get a raised to 9. What I do is I can convert this to a cube minus 1 format, right? A cube minus 1, the factors are a minus 1, a square plus a plus 1, right? Now if we have this but we don't have this, so what we can do is we can multiply both the side by this. Okay, so what we'll be getting, a cube minus 1 is equal to 0 into a minus 1, that's further 0. So a cube is equal to 1, a raised to 9 will also be 1. Pretty simple. Okay, once again similar pattern of problem. Let's break it. It will be x minus 1 upon x plus 2, right? X square by x, x minus 1 upon x plus 2. So precisely we wish to have the value of x minus 1 upon x. Here we are given x square plus 1 upon x square. So x square plus 1 upon x square, I add 2 is equal to 68. Okay, I want x minus 1 upon, so I need to deduct 2. Okay, then only it will be x minus 1 upon x whole square. So it is 66 also minus 2, so it is 64. So x minus 1 upon x whole square is 64. So this is actually plus minus 8. So if you take 8, 8 plus 2, 10, one value, minus 8 plus 2, 6, minus 6, other value. So 10 and minus 6. Pretty simple. Now in examination, nobody asks you this unnecessary complicated problems. It is just the problem is with us only. We are not able to think out of the box. Now in this case, A and B, we got very weird values, right, in decimal values, right? So we should be able to think something. It's 9a square, 16b square. Just try to see, this is 3a whole square, this is 4b whole square. Now what about this? If it is 3a whole square plus 4b whole square, if we wish to have a 2ab format, 2xy format, so the third term should be 2 into 3a into 4b. Is it this? 4 3s are 12, 2s are 24 AB, right? So precisely what it is, 3a minus 4b whole square. Since it is minus sign over here, we'll be having minus sign over here. Okay, if it is plus, it will be plus over here. Now 3a minus 4b whole square. Now the story becomes very simple. A is 2.5, 3a will be 7.5. B is 1.5, 4 into 1.5, it is 6. So it is 1.5 whole square, that is 15 square divided by 100. So 15 square to 225, 2.25. Your answer is pretty simple. Just have to think that it is 3a minus 4b whole square. Once again, x square minus 1 upon x square, right? So x minus 2 whole square is equal to 5, x square minus 4x plus 4 is equal to 5. So x square minus 4x is equal to 1 divided by x. X minus 1 upon x is equal to 4. X square plus 1 upon x square minus 2 is equal to 16. But we want x square minus 1 upon x square. For that we need to have x minus 1 upon x and x plus 1 upon x. So here x square plus 1 upon x square minus 2 is equal to 16. So this is 18. Now I want x plus 1 upon x, so I just add 2 both the sides. Okay, now x plus 1 upon x whole square is 10. That means x plus 1 upon x is equal to root 10. So this is precisely root 10, and x minus 1 upon x is 4. So your answer is 4 root 10. I'm sorry, it was 16 and it's 20. That means I can take 4s outside, so it will be 8 root 5. Okay, I just missed this one actually. 4 square 16, then we added 2, so it is 18. Further I added 2 to make it x plus 1 upon x square, so precisely it is 20. Okay, be careful in calculation. X is equal to 6 plus 1 upon x. Value of this, again very simple problem. It is 6 x square plus 1 upon x square is equal, minus 2 is equal to 36, so it is equal to 38. Then x4 plus 1 upon x4 plus 2 is equal to 38 square, so 38 square minus 2. Okay, no need to calculate the entire thing. 8 square, the unit digit of this must be 4. 4 minus 2, your unit digit must be 2, so that's just one option over here. Okay, so do not expand 38 square. And once again, if you have two options, then just calculate the digital root. 8 and 3, 11. 11 square, that is 121. Digital root is 4. 4 minus 2, your digital root must be 2, right? So just check. It's 4 and 4, 8 and 1, 9. Digital root is 2 over here. It is 12 and 1, 13, 4, 6, 8. Okay. Now I'm sure you must be getting the problems, and you are able to solve the problems very easily. this and this we have to find out. First of all, the simple thing, just take the reciprocal, 2x square plus 5x plus 1 by 5x by 5x by 5x is equal to 3. So this is okay, 2x by 5 plus 1 upon 5x is equal to this is 1, so 3 minus 1, 2. I want x plus 1 upon 2x. I just remove this 5, so it is 10. Okay, so I'm having 2x plus 1 upon x as 10. 2x plus 1 upon x is 10, but I want x plus 1 upon, so I don't want 2x. So what I do is I divide this entire expression by 2. So I'll be getting x plus 1 upon 2x. Since I divided by 2 this side, so I need to divide it that side also, so it's 5. Pretty simple. If x minus 1 and x plus 3 are factors of this, then see, if x minus 1 is factor of this, that means if you put x is equal to 1, the value of this expression to be 0. So put x is equal to 1 and equate it to 0. So 1 plus k1 plus k2 is equal to 0. That means k1 plus k2 is equal to minus 1. Now from the options, just add k1 and k2 and see where do you get minus 1. Here you do not get, here you do not get, here it is just 1, here it is minus 1, right? So no need to work further. Pretty simple. If AB plus BC plus CA is equal to 0, then value of this expression. Now it is very difficult for us to assume the three values, right? When combination of the mutual two values sum is 0, right? AB plus BC plus CA is 0. So I cannot assume the three values of ABC. So what I do is to make the problem simple, I assume the value of 2 and I put the value of the 2 in this equation and will get the value of the third variable, right? So that will be pretty simple. So what I do is I put A is equal to 1, B also 1, and in this equation and get the value of C. You can take any of them. So AB plus BC plus CA, AB will be 1, BC will be C, CA will be also C, it is 0. So 2C is equal to 1, that means C is equal to minus 1 by 2. Okay, when A is equal to 1, B is equal to 1, C is equal to minus 1 by 2, and these values of ABC satisfy this equation, because from this equation only we have calculated the value of C. Okay, now the problem becomes very simple. We just have to put up the value of ABC, 1 upon A square minus BC. So A square is 1, BC is minus 1 by 2, right? 1 into minus 1 by 2, minus 1 by 2, and into minus sign, so it is 1 plus 1 by 2, plus 1 upon B square, that is 1, minus AC, once again 1 by 2, plus 1 upon C square, that is 1 by 4, minus AB, that's minus 1. So this is 1 upon 3 by 2, so it is 2 by 3, it is 2 by 3, so it is 4 by 3, plus 1 upon 4 minus 1, that's minus 3 by 4, so minus 3 by 4 in the new this, so precisely it is minus 4 by 3, 4 by 3 minus 4 by 3, 0. So when you see that you cannot assume the value of all the variables, you cannot make such combination in your mind, and you cannot waste your time in obviously in thinking of the three values where AB plus BC plus CA is 0, right? So assume the value of two variables and get the value of the third variable by putting the value of the two variables in this relation, right? So that will be very easy. You can choose any other values also, right? But do not generally we should not choose the values as 0 0, because in that case, if at all even a single value you choose as 0, then the third value will automatically be 0. See, if you choose just A as 0, so this expression will be 0, this expression will be 0, automatically the third one will also be 0. So avoid that. That will be an unnecessary time wastage. Okay, you will not be able to get any value out of it. Okay, I hope you are clear.